Okay, so we're going to be looking at the long range forecast for the Coachella weekend from the 11th to the 14th. Now, like I said, this is I've said before that this is long range, so I have to, but it doesn't really matter. Okay, you could kind of assume that this is going to be what it is since we're less than 14 days away. We could go, okay. Um, so this is one weather model, the GFS. This basically takes 31 members. So essentially, like 31 possible realities. It takes like the answer from all of them and like tries to make a. So here's Coachella for April 11th through the 14th. Watch, I'm just gonna go through the whole thing. There's a very simple forecast because there's not really much to see, but for the 11th through the 14th, you get 0% rain possibilities. You get up to 3%, on the 12th, but whatever, but 6%. But really, anything for me, anything that goes under 50 is it doesn't really matter. And there's less than 10, so and something else you wanna like which one has the highest out of all these days? Okay, this is the 14th. This one doesn't even go. So which one had six? Six had okay. April 13th at 5 a.m. That is hour 276. Okay, here. 6%. Um if I go to model trend loop, which is it takes something they want to do with forecasting is that you want to see different like to explain models is that they come out every 6 hours. Like the Z's are this is like military time essentially. So 12Z is 5 a.m. Pacific Standard Time, 0Z is 5 p.m. Pacific Standard Time, and then you have the ones in between, 6Z and 18Z. Like 6Z is like around like I don't know, like 10 p.m. or something. But you want to take at least the last four runs. So, 18 to 18 or 0 to 0 or 6 to 6. And you want to like see what like the averages are. So, and the last few averages, it was giving out 0, 0, 0, 3, 6. Well, like the average is like 3%, 3%. So that's not a lot. That's one weather model, though. This one, like I said, this one's taking 31 alternate realities, and out of 31 realities, in over 95% of them, there's no rain. So like I said, anything less than 50% doesn't really matter. There's another one, the European model, which takes 51 alternate realities, and again for the 11th through the 14th, 0, 0, 0, 0, 0, 0. This one has even less possibilities. 4%. So yeah, anything. So there's no rain for that time. For temperatures, I'll just go 24-hour max. Oh wait, but okay, let me go back to I can see the whole week. Mm, okay, you see that temperatures are gonna be it's kind of covering a little bit. Okay, temperatures are gonna be like around or like the mid to high 80s is what's forecast. Mid to high 80s from the GFS. The EPS is giving 85, 88, 89. So mid to high 80s for the Coachella Valley. Something that can sometimes increase like the feel of the heat, so it feels more than it actually is dew point. But since it's a desert, I don't expect dew point to be that high. Here we have 40, 40, 40. So for example, this day has like what's the peak? Like let's say this one has 30. Okay, wait, well, let me just go back to the hottest day that like one of the hot days it said. The one that's in like 80. Okay, 89. 89. What time is this? 5 p.m. So 0Z the 13th. Oh, here it is, I think. Yeah, 89. Okay. So you have an 89 temperature and you have a 28 dew point. I think I have a bookmarked somewhere around here for heat index. So you have a, what was it? Okay, I have you have a 28. Oh wait, relative humidity. Okay. You have a 13 relative humidity and 89 temperature. So actually it's gonna be feel cooler than it actually is. It's gonna be 89, but it's gonna be like 85. So yeah, so like expect mid to high 80s for the Coachella Valley during that time. Uh for wind during that time. Let me just go back to the GFS. Uh wind during that time. Oh wait, let me go forecast loop. Coachella Valley was somewhere around here. So substantial wind is not expected, or at least according to the GFS, but I've noticed that weather models are kind of bad, or like not bad, but they're not really good at predicting weather. I mean, wind. So let me go back to, yeah, you could maybe get up to the 15 miles per hour, but that's I wouldn't consider that windy. But just assume that because it's the desert, you are gonna get some wind no matter what. Here's the EPS. It has a little bit more in the 20s, which is still not that high. 28, that's like when something over 30, once you get to here, you can kind of say, okay, maybe it could be windy. 29. But like I said, the other one didn't even have anything close to 29, so you're just gonna have to assume anyway that it's gonna have some type of wind component during that time. And just, I mean, not even that time, just because the desert is like that anyway. Okay, but that's long range Coachella. Now, something a little bit more short term is the, okay, I think I'm just going to the GFS. This was more, once you get under the 120 hour, like I said, these are called ensemble. Like the ensembles are basically like different realities, and because after a certain something so far away into the future, you can't really just take one individual. You can't see one individual reality, for example, and guess what you're trying to see. You have to take multiple. Like these take in total, we saw like in total, because 30 plus 50, you saw 80 different realities, and in 80 realities, most of them were in the 80s with no rain. So, but once you go under 120, you can kind of just use these, which are like, they're just trying to give you one answer instead of multiple. So now that we're in the 120s, we are expecting some rain this week for Los Angeles. As soon as Thursday probably. I know I said that you could just check it for this. The you could see rain possibilities for GFS. Like I said, 50 over 50. Okay, now you got 68% in the anything 6 hours before 11 p.m. to 11 p.m. Thursday. You already got into 60s. Let's see how often that pops up. 78. So this is I'm assuming this is this. Okay. So the last, like I said, you want to see the last 4 runs. Okay, 0 to 0, 87, 84, 68, So you got over 50% in the last 4 runs. That means, okay, so that's something to consider. Let's see what EPS says. For the same time frame. What time is this? 506. 506, 506. Here we go. Let's see what this says. You can see here 18 to 18, 30, 20, 30. EPS doesn't go higher than not even 40% in most cases. So, there's a disagreement between the GFS. GFS is saying, oh yeah, there's definitely going to be rain Thursday night. And EPS says, no, there's not really that high a chance that there's going to be rain Thursday night. So you're just going to have to take the averages of both and see what. So I don't know, I could just use this manually. What is this? 80 is the highest. Okay, 87 is the highest. And 61 is the lowest, so like around 75% chance. And here 20, like around, like I'll say like 30%. The one has 70, like I don't know, whatever, 30. I don't know. It's like a 50-50 chance that it's gonna rain on like Thursday night. But when they both start agreeing, is okay. 5 a.m. we got 51%. Is that throughout the last 4 runs? We go 18 to 18, so 50. Nope, it didn't do the whole full run. It's almost a whole full run, but just to be sure, that means I bet this one does have the full run. 60, 70, 70, 70. Okay, 11, 10, 9, 8, 7, 6. So from 5 to 11 a.m. currently forecasted is there's 96 hours into the future, but from 5 to 11 a.m. Friday, you could expect rain. What did I say it was 96 hours? I bet you this one says the same thing. 0 to 0, 60. So they're both, GFS and EPS are both saying rain over 50% for Friday morning from 5 to 11 a.m. So that's how it's basically saying, okay, so yeah, it probably is gonna rain. Rain is likely. Rain is likely starting Friday morning. I don't think any other model is in range because how this is 102 hours. I know NAM isn't. I know maybe the only one I could think of that's in range is Shield. Shield, the Western U.S. Precipitation, reflectivity. Okay, so well, for starters, here's Los Angeles. Angeles is right here. So you can see this is 8 a.m. Friday morning in Los Angeles, and you can see there's rain cells over the area. So yeah, and there was some before that. Like there's like this is before 5 a.m. Friday morning. There's like 2 a.m. Friday morning. And there could be some rains. This one also kind of showing like some signs that it could be raining as late as Thursday night. I mean, as early as Thursday night. One of that could be in range is the SREF. Recip. Here, I'm just gonna go here. Percentages of rain. So here's Los Angeles again. Los Angeles is right here. And what time is this here? This is Thursday night already. And this one also starts the rain around early Thursday morning before 5 a.m. It goes above 50%. So yeah, just most likely explain. It's gonna be raining Friday. Now, how heavy is it gonna be raining? Probably not a lot. Um, I mean, here's a total quantitative rain totals. I mean, GFS is looking at 0 point less than half an inch of rain. And this isn't forecast loop, right? Yeah, it is. And EPS is looking at also way less than half an inch of rain, so it's not going to be a lot, and it's probably only going to be for Friday only. 50, 90, yeah, you go back, it goes down less than 40 by Friday night. And so does GFS, I think. Yeah, this is so like not even, so just mostly Friday morning, a little bit of rain, most is what's being forecasted. So yeah, that's the rain for here. Now here's my area of expertise. Tornadoes for tomorrow, April 2nd, Tuesday. Now, we did have tornadoes today. I wonder, I have no idea how to do this. I have no idea how to check. Oh wait, I think I could just check here. We did have tornadoes today. We had 1, 2, 3 reports of tornadoes today in Oklahoma. A tornado crossing. Public reported a tornado on the ground southeast. Okay, so we had 3 tornadoes today. Is this the most updated version? Pretty sure it is. Yeah, we had 3 tornadoes today. At least reported. I know there's one that happened not too long ago, like 15 minutes ago, as the time we were recording at 9:30 p.m. Pacific Standard Time. I know there's a tornado somewhere up here today, like 15 minutes ago. But okay, tomorrow is being forecasted as another tornado day. Now, where if I was a storm chaser out in the field, I already know off the bat that it's gonna be like not even like intuition. I just know this because I checked a little bit before the weather models before I went live. But I know that I know that by 21Z, which is like 4 p.m. Pacific Central Standard Time. By 4 p.m. Central Standard Time, we should be moving into a tornado time zone, like an area we could see tornadoes. Now where? Like this is how my method of narrowing it down. Now this is a bunch of different. I'll go to the like first. I should have started from the beginning, but this is the College of DuPage weather website. You could just go to weather, College DePay's weather. Go to weather data is where I go. Numerical models. A lot of people use this. I'm not the only one that uses this. For like the day of, or like the night before, which is what I'm doing right now. I look at the North American model, contiguous United States, and I start at the surface. Out of all these options, I start at the surface, dew point temperature, and like I said, I already know that it's 21Z tomorrow. So up here you can see 21Z Tuesday, April 2nd. So 4 p.m. Central Standard Time, Tuesday. And I have this little color thingy that I could color in. It's called Epic Pen on Windows. Okay, so this is basically dew point temperatures, which is like how humid the air is essentially, and thunderstorms, and also by association tornadoes, which is just the most dangerous type of thunderstorm. Tornadoes like 60s dew points, which is, there's a dew point temperature is how humid it is. The more if you're like in 80, if you're like in 75-degree weather with like 65 dew point, it's gonna be very humid, very sticky air. Okay, tornadoes and like specifically like 60 dew points and above. So you can see right here, here's your like legend. 60 dew points and above is colored in blue. And you can see right here, like Los Angeles is in the 52 dew points tomorrow. And here's your 60s dew points, all of this in blue and above, which is blues and purples. So what I like to do is color in my dew points. And this is a big chunk of the United States. Basically, we're gonna narrow our tornado target. Um, so this is, it's going down from Louisiana up into, Indiana, Ohio, and to the eastern seaboard. But I can't chase. You can't chase. You can't be chasing this whole thing. So the second thing I go to is the 850 winds, the 850 millibars, which is essentially the winds 1 kilometer above the above the surface. The 1 kilometer above the surface, you go to wind speed, and everything that's colored in yellow is your like here you can see everything that's colored in yellow is, and above is your 30 knot wind, and that's what's favorable for tornadoes. 30 knot winds and above, and the higher you go, the more favorable your tornado area is. So yeah, you can see everything that's already colored in green, you just color it in yellow now, and just going along where the 850 winds are above. Like you see, this is a big area where there isn't. So yeah, I'm just gonna, so I don't get confused, I'm just gonna dash this area by saying, no, it's not. Ignore this area. Now, the traditional way you're supposed to do this, the traditional way you're supposed to do this is top down. So you're supposed to go from 850 and then go make your way down. I use surface and go all the way up. But here you can see for tomorrow, there's going to be what's called a trough, which is basically this vaguely U-shaped. This is up to there's actually like 5 miles up in the atmosphere. Here you can see something called a trough, which is a vaguely U-shaped like river in the atmosphere. You can see it's vaguely, if you see these black lines right here, and I color it, I don't know, something that's colorful with this, you can see that it's vaguely U-shaped. Like this black line goes like up here, so it's vaguely U-shaped, and that's called a trough. So tornadoes, if you split this trough in half, tornadoes are usually on the right side of this. Not usually, they're like 80% of the time they're on the right side of a trough. So if the middle is like right here, then everything above like you can see the wind speeds right here. You see green, yellow, red. Anything over 30, which is basically anything that's not white, is your right, and it's also on the right side of the trough. Anything here is favorable for supercells, and supercells are the type of thunderstorm that create tornadoes in the first place. Not only tornadoes, they create any type of severe weather. But if you're on the right side of the trough and you have 30-mile-per-hour winds or 30 knot winds and above, you see at 500 millibars, so 500 millibar winds above 30, right side of the trough, that's your area that's the first place you have to look for tornadoes. So you can see this area was I already knew that it was going to be a favorable area. That's why I didn't start at the top and I started from the bottom up. You can see that all the area I was coloring anyway is in the right side of the trough above. Here you have 50, 70 knot winds, so that's more than enough for supercells. 850 is the yellow part, the dew points. So to narrow it down even further, you go into what's called, you can either use mean layer CAPE or surface-based CAPE, and what these two measure is instability, and instability is, as how like the name suggests, is how unstable the atmosphere is. If you go to surface-based CAPE, anything over here's your legend out here: 500, 1,000, 1,500. Anything 1,000 and above is favorable for tornadoes. So if you color, you can see there's pink and like this is whole area we drew, but there's like pink and colors that are not over 1,000. So you just start coloring in anything that's blue, essentially anything that's in the surface-based CAPE option, and anything that's over blue. You can see that there's areas where like it's super bright here, and then there's like blue here that's kind of like dimmed out, like it's not that dark, it's not that bright. That's called this, because this area, if you see, if like in the square, you can see like this, it has the CAPE like 9, it has CAPE 9 and then SIN -0. The negative number is your convective inhibition, which is like your negative CAPE number. You're basically subtracting with the top number by the bottom number, and then that's your like total CAPE. So like here, there's 1,100 CAPE, the top number, but there's -100 SIN. And so for tornadoes, usually anything over 30 is saying, oh, this area is not favorable for tornadoes. So like here's over 60, but you can still color it in because there's special cases where that doesn't matter, that the number is too high. There's cases where the negative number is over 100 and there's still tornadoes, strong ones, and I'll explain later why that doesn't matter. So now that I drew all the blue, you can see it's now I narrowed it down. I basically ignored all the, like, I ignored Alabama, I ignored Georgia, I ignored southern South Carolina. But you still have this like big area from what is that, from Louisiana all the way up to Indiana. And so you can't chase this whole area. Obviously, this is like a 12-hour plus drive. So to narrow it down even further, you go back to 850, which I already was at, and you could look at something called temperature advection, which is what you're looking for here is something called warm air advection. You can see how like there's blue colors and there's red colors. Warm air advection is in the red colors, and this basically means that warm air is entering into the area. And this is like a little bit above my pay grade, but tornadoes are more favorable in areas with warm air advection. Oh, it promotes rising air, which is how thunderstorms become even stronger than they are in cold air advection areas. So you look for warm air advection, and in the College of DuPage website, if you click down for 1 second, if you left click on any area for 1 second, you start getting your model weather. Where's my mouse? Oh, here it is. You start getting into your model weather. So this is basically a picture of the atmosphere um like it's telling you a bunch of information. Like here, your top left is telling you the temperature of the atmosphere going up into the atmosphere from the surface at 0 kilometers all the way up to 15 kilometers up into the atmosphere. It's telling you your CAPE, as I said. You know, I said anything over 1,000 was good. And it's telling you all this information that I'll go into. I will just go into it right now and just tell you what to look out for. So this is this top left is called your SQT, which is basically, like I said, the temperature of the atmosphere up in the air as you go up. You can see here it starts at the surface with a 65 dew point, and I said anything over 60 is good. And you have a 80 surface temperature. So for tornadoes, you want to look for this number and this number to be less than or equal to 15. Now here you have a 65 dew point and 80 surface temperature. So that's okay for that category. Now for tornadoes, here's your CAPE values, and you can see you want to look for the ML CAPE row, because that's just the more favorable thing to look for tornadoes. And here you have an ML CAPE. Here it's telling you like ML CAPE over 1,000. That's good. Your inhibition, your negative number is less than 30. That's good. Okay, here's your LCL, which is this thing right here. LCL. They say it twice here. Your LCL is the height of how tall the bottom of the clouds are gonna be. So usually you want this number less than 1,500, or in most cases you want it less than 1,000. Here it's a little bit too high, but I've seen cases where it's even higher than that. But okay, you want it less than 1,000, or at least, or at most 1,500. And here it's okay. LFC, which is this yellow thing right here. Your LFC, you want it less than 2,000. Here it's 1,700, and so that's good. That's another check mark. And you want these to be close. If the LCO is like right here and the LFC is like all the way up here, then that's not a favorable environment for tornadoes, because you can't have them too separate. Here they're kind of close. They're pretty close. So I would say that that's a good check mark here. Here you have your 3 CAPE. And like I said, this is your it's called the mixed layer CAPE. Your 3 CAPE is basically your CAPE at the lowest 3 kilometers. You can see here the 3 kilometer, and under is your 3 CAPE. Anything over 50 is good for tornadoes. Here you have 55. So that's another check mark. It's like, okay, so here you have your lapse rates. And basically this is how cold the air is getting per kilometer, with Celsius per kilometer essentially. So from the surface to 3 kilometers in the atmosphere, you're dropping 7.4 Celsius per kilometer. So, and for tornadoes, you want this number over 6.5 or 6.7, 6.8. So 7.4 Celsius per kilometer are good numbers. Okay, now here you go. This is like your temperatures. This is called your thermodynamics for your atmosphere. And all of these are actually, you can put check marks on all of these because these were all pretty good, are adequate for tornadoes. Now here is called your kinematics, which is essentially the winds. Now here's your surface to 1 kilometer SRH, which is storm relative helicity. And for these numbers, you want it over 100, 150. Here you have it 165, so that's a check mark. Your surface to 3 kilometer SRH, you want it over 200 to 250. Here's at 268. Your effective inflow layer, you want it over 150. Here's at 152. Your surface to 6 kilometer, you want it over 30 for supercells, which is like the first ingredient you need for tornadoes. And so if this number is over 30, that's already a check mark anyway. So here's at 65. Also, you could look at effective shear, and that's at 64. So if these check this number first, and if that's over 30, that's good. So if both of them are 30, that's even better. But primarily, if this number is over 30, that's good for supercells. Your 46 storm relative winds, if it's over 15, that's good. But I've seen a lot of not a lot of cases, but I've seen cases where it's under 15 still create tornadoes. But okay, the your average number is over 15. Here's at 28, so that's good. Bunker's right is basically how fast your storm is moving. So here's your the this if a tornado formed in this area, it will be like typically moving at 42 knots, which is pretty fast. Especially where did I get this sounding from? Here, I got it from the border between Alabama and Georgia, or not, Mississippi and Alabama. So that's a pretty forested area. So, 40 knot winds is pretty fast. You're basically you're gonna have to be going at least 40 miles per hour by car in a forested area chasing tornadoes. But okay, that's even if tornadoes are happening anyways. Uh, this column right here, you want to look at 850. Here's what I do. You go to 850, which is this line. You go all the way to this, and you see that this blue box right here, like this blue thing. Usually, it could be like a box the size of this, but right now it's like a blue line. This is your, yeah, 850. This is your warm area advection, like the thing that we used to like locate this place in the first place. Um, like you can see that we were checking this area here, and we saw that this area is under warm area advection, and you can see here is your this big warm area advection. The smaller warm area advection, the smaller the box is. But here there's 850 warm area advection. That's good. Here's your hodograph, which is basically plotting this like in a graph, essentially a hodograph. And for tornadoes, you want this to look, ignore this, like this whole mess for a second. You want them to look like this, actually. You want them to look like a hook or like a backward 7 almost. Like here's a 7. You kind of want to look at it like kind of like a backward 7, and this is kind of what it looks like for tornadoes, and that's good. And you want this number here to be over 45, and that's actually what's happening here. You have a hooked photograph over 45 degrees critical angle, and like I said, here's your 42. There's the same number here, but it's just plotting it like here. So if storms happen in this area, they're going to be moving at 42 knots to the, essentially to the east, northeast. And this is kind of a way to figure out what storms are like tornadic in the area, because you could start it from here, and you can see this like yellow square here is how fast non-tornadic storms are moving at. So you can see that these are moving at 60 miles per hour. I'm just gonna say it's knots, but I'm just gonna say in miles per hour. It's 60 miles per hour, non-tornadic storms, and then if it's tornadic, it's gonna slow way down to 40. So like when you're seeing radar, you kind of have an idea of which ones are being tornadic because they're way slower than the other storms that are in the area. But overall, I would say that this could be. I wasn't even thinking. I was just showing this as an example, but this is looking like a pretty favorable environment for tornadoes tomorrow afternoon down in the southeast. But that's just one of the lot of areas that kind of fit our category of storms. This was like down here. We actually have another one down here. Let's see what this sounding says. This is a big mess. Let me just erase some of this here. I don't need this. I don't need that.